Right, grade 12. So this video is just to run through a whole lot of different trig questions, right from the Pythag type to using the compound angles, the double angles, identities, everything. So I'm going to start. The questions are uploaded onto your Google Classroom, and we have the questions here at the top of each of the pages. So the first one is, if cos 32 equals m, find these ratios in terms of n, and then it runs through 5 questions. But before we start looking at the ratios, we've got to start looking at what the question actually meant. If cos 32 equals m, it's implying that you're working with a Pythagoras situation. What I like to do is I say m over 1, cos is adjacent over hypotenuse. And then we're going to draw our triangle. Now, how do we know that we're working in quadrant 1? It's because 32 is given to us, and 32 is between 0 and 90 degrees. What I've also done here is I have filled in the 58 degrees in the triangle because of angles of a triangle. And so if you can get any of the questions down to a 58, you can also use the triangle directly. So from 32, we're going to go adjacent is m over hypotenuse is 1. And so we've got to work out the opposite, or the y value. Now, all of the values are going to be positive because we're working in quadrant 1. If we were working in quadrant 2, you would have positive y values, negative x values. Quadrant 3, you'd have negative x values, negative y values. And then quadrant 4, negative and positive. So in order to find the y value, we're going to use Pythagoras. All right, so here's the Pythagoras done for you. Please just make sure that you only use the positive root. You're supposed to say plus minus, but because we're working in quadrant 1, everything is positive. If we were working in another quadrant, you would have to take the negative root if it was, for example, quadrant 3 or quadrant 4, where y is negative. In this case, y is positive, and we do not square root the 1 minus m squared at all. You can't say square root of 1 square root of m squared because it's a binomial. You must leave it as is. So then that piece becomes your y value. All right, and that's going to go onto your triangle. So your triangle now is going to be focused on just that information. We don't need anything else except for our information that is with regards to the triangle that we found now. So now we go to our questions. All right, so the first question is sine 148. We need to change that to something that has m's in it. So no sines, no coses, no tans. It must have numbers and m's, or numbers or m's. So we need to reduce. Because sine 148 is bigger than 90 degrees, we cannot use this triangle. This triangle is only working with acute angles. So we need to reduce it using our cast diagram. So your cast diagram, we've got to go find where is 148 on the cast diagram. So I've drawn one just on the side here. So 148 sits between 90 degrees to 180 degrees. So we're going to say 180 degrees minus something that's acute will get us to 148. Now if we use our calculators or just in your heads, we work out that it would be 32 degrees. 180 minus 32 would get you 148. So now that means I've got a 32, so I can go into my triangle and work from 32 and do sine. Sine is opposite over hypotenuse. So from 32. So opposite from 32 is root 1 minus m squared. The hypotenuse is 1. But because we're working with the denominator as 1, we don't actually need it. We can leave the answer as 1 minus m squared under the root sign. All right, our next question is cos negative 58. Now, when you're working with a negative angle, you act as if you are in cos's quadrant. So cos of a negative angle, because it's in its own quadrant, we work with the positive angle. Cos stays positive, angle goes positive. So now either you can use a co-ratio and make this sine 32 degrees, and then work with the same answer from 2.1. Or because we've got 58 degrees in our triangle, we can go in our triangle, cos is adjacent over hypotenuse. So from 58, start at 58, adjacent, next to it is 1 minus your m squared, there it is, over your hypotenuse is 1. Which means that you can just leave off the denominator as 1, and it is the same answer as sine 32 because they are co-ratios. Co-ratios mean that when you have sine 32 and cos 58, the 58 and the 32 add up to 100, add up to 90. And that means they are complementary. Mathematically, complementary means adds up to 90, supplementary adds up to 180. So they are complementary. So they have the same value. So they are interchangeable with each other. All right, so we'll come back to that when we're working with some identities and some reductions. All right, so now the next question, sine 244, we've got to reduce it. It's too big. It can't work in the acute angle triangle. So we have to go into our cos diagram, and it sits in tans quadrant. So this is 180 plus something gets us 244. But because we're working in tans quadrant, sine is going to be negative, and it ends up being negative sine 64. So it would have been 64 degrees taken added on to 180 to get 244. Now, the problem is we don't have 64 in our triangle. But if you think now, where's the metric work in all of this? 64 is double 32. So we can rewrite 64 as 2 times 32. Now we have our double angle formulas, and that means I'm going to bank that negative there. This sine 2 times 32 becomes 2 sine 32 cos 32. That is the representation of a sine double angle. It's one of your formulas, one of your identities. So now instead of sine 32, we can put in our opposite over hypotenuse from our 32, and instead of cos, we can go adjacent over hypotenuse from that point. So I'm going to bank the negative 2, and then I'm going to say from sine 32, we said sine 32 from 2.1 was the same as root 1 minus m squared, and cos 32, they told us from the original question that it is equal to m. So now let's just rearrange it to make it look nice. So we have negative 2m into the root of 1 minus m squared. Please don't multiply into the root. It is not a bracket, and please don't square the root away. We're not working in an equation, we're just simplifying. So if you want to square, you'd have to square both sides, and you don't have another side. It's an expression, not an equation. So now for the next one, it's cos 296, which when we reduce it, we're going to end up getting into cos's quadrant, and it's 360 minus 64. So again, that is leading to a double angle of 2 times 32. Now, cos has 3 double angles. Doesn't matter which one you pick the one that you like the best, but in this case, I want to pick the one that only has cos's, because then I can use the question. I don't have to rely on my triangle. So I'm going to go with 2 cos squared 32 minus 1. And so instead of the cos squared 32, I am going to be putting cos 32 is m, but it's being squared minus 1. So all I'm left with is 2m squared minus 1. Please don't forget that, so it's cos 32 is represented by m, so cos 32 squared means it's cos 32 times cos 32, m times m is m squared. Okay, the last one's a bit tricky because it's cos 26. Now it's already reduced for you. It's not 32, it's not 58 from your triangle. It's not a double angle of either of the two. So it's got to be something else. Normally, if it's not a double angle, it's not a co-ratio, it's not a reduction, then look for a compound angle. So in this case, you've got to recognize the fact that if you take 58 and you subtract 32, it's the same as 26. So instead of cos 26, I've replaced it with 58 minus 32. So now this is the cos compound angle, which goes cos, cos, sine, sine. Take the opposite of what's in the bracket and then give each angle a chance with each ratio. So from your 58, you're going to go adjacent over hypotenuse, and then from your 58 with the sine, you're going to go opposite over hypotenuse. Then you're going to do the same thing with cos 32. So from 32, you're going to go adjacent over hypotenuse, or you can use the question said cos 32 is m, and sine 32 is adjacent over hypotenuse from 32. And then just finishing up, if we get rid of all our denominators of 1, we have m times the root plus m times the root. So I have 2 of those, 2m roots, 2. So m roots plus m root is 2m root, and that's your final answer. All right, for the next question, it's another Pythagoras one, but just one where it's not going to necessarily be in the first quadrant. It's going to be 2 separate diagrams. So here it says if sine A equals 12 over 13, and A is obtuse, and tan B is 4 over 3, and B is greater than 90. Now you've got to answer all these questions. So when we're working with sine A, remember that's opposite over hypotenuse. Sine here is positive, and so where is sine positive? First and second. Angle A is also obtuse, which means that it is bigger than 90, but smaller than 180. So where's bigger than 90? Over here, smaller than 180. Because once we start going further than that, it starts becoming a reflex angle. So we're working in quadrant 2 for this one. There's our triangle. Always go from the center, from the origin, outwards diagonally down to the x-axis. Draw your triangle like that. Opposite from here, this whole angle is angle A. It's obtuse. We pretend we're working in that little tiny one, a reduced angle. So we have opposite over hypotenuse. And we'll be able to work with Pythagoras to work out that third side. I'm picking -5 because we are working in the second quadrant. The x's must be negative, but the y's must be positive. So using Pythagoras, you'd find the third side. All right, then for the B diagram, you've got to think tan is positive. So where's tan positive? First and third. But B must be greater than 90. Greater than 90 is second, third, and fourth quadrant. Where we get the double tick, that's where we're going to draw our triangle. So again, the whole angle is B, but we pretend we're working just with the reduced one inside. And tan is opposite over adjacent. So opposite is 4, adjacent 3. But because we're working in the negative x and y quadrant, we've got to make sure that we have negatives. So this fraction 4 over 3 is actually -4 over -3. But negative and negative make positive. And then using Pythagoras, you'd find the hypotenuse to be 5. And a hypotenuse is always positive, always. All right, so our first question here is sine bracket A minus B. Please do not just now substitute in sine of A, sine of B. It's once you've got the diagram, you have to have sine and then A directly touching it, sine, B directly touching it. As soon as you have the bracket, you need to expand this into the sine rule, which is sine, cos, and then cos, sine, and you keep the same sign for sine, and each one gets a chance with each angle. Now you have sine directly with A, you have cos directly with B. So now that they're directly touching their angle, now you go to their respective triangles. So for this, the A, you go to the purple triangle. For the B, you go to the red triangle. So you're going to go in the purple opposite over hypotenuse, the red adjacent over hypotenuse, etc. Alright, so from each triangle, there's your substitution, and then you're going to work out your final fraction. So the first one is negative 36, and then you're going to be subtracting positive 20, and so your final answer is going to be negative 56 over 65. Now for 3.2, we're going to do exactly the same thing. We're going to expand the cos compound angle. But just make sure you have the opposite sign that's in the bracket, and it's cos, cos, then sin, sin. Then you're going to substitute in exactly like we did in the previous question. Same numbers, just different order. And that equals to negative 33 over 65 once you've substituted in. Opposite over hypotenuse, adjacent over hypotenuse from the correct diagram for the correct angle. The next one's just very lengthy. Because there is no tan compound angle, we've got to use sine compound over cos compound. But if we have a look at what they've already asked us to do, they've already asked us to work with sine A minus B and cos A minus B. So you can substitute your answers in from the previous two questions. I'm just dividing here. Negative 33 over 65. Tip and times, and you get 56 over 33. So if you were to only be given tan to start, you'd have to expand the top, expand the bottom, and then substitute in all the fractions and work them out. So the best way is just to use your previous answers. Alright, then the last question for this video, and then I'll upload the next one for the rest of the questions. It says use the compound angle formula to prove that. So now please note this is a prove that question, which means you're working left hand side, right hand side. So you can't bring things over the equal sign. You either choose to start with the left or start with the right, or you can do both but separately, trying to get them to look like each other. But you do not move things over as if it's an equation. So for the first one, we're working with half cos A plus B plus cos A minus B all in a bracket, and it must equal cos A cos B. So we've got to work with the left-hand side here. It is clearly the more complicated side. Alright, so what I've done here is I have already expanded the compound angles within the square bracket, the cos A plus B and the cos A minus B, as per the compound angles in each of the bubbles. And then we are able to see that the sine A sine B is negative there and positive on the end, so they're going to cancel out. So we're going to be left with a half into, we're going to have two lots of cos A cos B, and then when we multiply the half in, we're going to be left with just cos A cos B, and that is equal to our right hand side. Right, for our next one, we are working with cos 90 plus A. We need to prove that it is equal to sine A. Please be careful, you're not using straight co-ratios here. They want you to show where it came from, that you can use negative sine A for your co-ratio here. So we're going to use our left-hand side, and we're going to expand our cos compound angle, cos 90, cos A, opposite sign to the bracket, sine 90, sine A. And when you look at 90, it's a special angle. So we're going to subs in our special angles. Cos of 90 is 0 times cos A. And sine of 90 is 1 times sine A. So 0 times cos is 0. Negative 1 times sine is negative sine A, which is our right-hand side. So please don't just jump with the co-ratios. This is showing you where the co-ratio came from. Alright, our next one looks dreadful, but once you actually start working through it and you realize you've got some special angles involved that it's actually a lot easier than it looks. So we're going to start with our left-hand side, and again we're going to expand our compound angles here. So we're going to have, so once we expand it, we can see we've got lots of 30s, which are special angles. So we're going to subs in, instead of sine 30, cos 30, we're going to use the special angles. So sine 30 is a half, cos 30 is root 3 over 2. So now we're just going to have to group like terms. So we're going to have a half cos x plus root 3 over 2 cos x, which is going to give us 1 plus root 3 over 2, because of the denominator 2 being the same, cos x's. And then we're going to do the same thing. We've got a root 3 over 2 sine plus a half sine, which is going to give us 1 plus root 3 over 2 sine x. And now we can take out the common factor, which is our fraction, and then we're left with cos x plus sine x, which is the same as sine x plus cos x. So what we could do is we can already rearrange it. And then work out our right-hand side from that. That is our right-hand side. All right, 4.4 on this worksheet is, again, now we're working with some compound angles. So we're going to expand the compound angles, and then in this case we have a multiplication happening. So we're going to have to do some distribution. All right, so once I distribute, I've put some brackets, and you can see we've got binomials here. So we binomials multiply to binomials, we're going to FOIL, but because it's the same thing in each bracket, one's with a plus, one's with a minus, you are effectively going to be doing a dots. So we are going to be getting sine times sine is sine squared A, cos times cos is cos squared B. Then if we multiply this whole term across, we're going to get negative sine A cos B, sine B, but then we're going to have the positive of it again. So we're going to drop that purple completely, and then we're going to multiply the last ones here. Cos A times cos A, but it's negative, is cos squared A, and it's negative because I've got a minus there, and then sine squared B. So the middle term falls away because it's the dots. They cancel each other out. One's a plus, one's a minus of the same thing. So then now we end up with sine squared A cos squared B minus cos squared A sine squared B. And we need to get to only sine squared A minus sine squared B as the right-hand side. So in other words, I need to make sure I get rid of the causes. There's no causes on the right-hand side. So we're going to use a handy little trick from grade 11, and that's to change using our identity. Cos squared of an angle is equal to 1 minus sine squared of that angle. And same thing here, 1 minus sine squared A times sine squared B. Right, so look at the right-hand side. It has no causes, so get rid of the causes. If I now distribute some algebra here, I'm going to get sine squared A minus sine squared A sine squared B. And then I'm going to get the same thing here, but be careful. We are working with, it's going to be the sine being distributed and the negative being distributed. So effectively I'm distributing a negative sine squared B in. So it's going to become negative sine squared B times 1 and negative sine squared B times the negative sine squared A. And then we see that that piece and that piece are the same, but one's negative, one's positive, so they cancel out, and we're left with just our sine squared A minus our sine squared B, which is our right-hand side. So unfortunately here, there's a lot of algebra that can go wrong. So you've got to make sure that you polish your algebra, you're foiling, you're distributing, and don't forget those negatives, and don't forget the brackets. All right, second last one for this video. We are working with cos 45 minus x minus sine 45 plus x. So again, we're going to work with our left-hand side because our right-hand side is equal to 0. It doesn't help us. So we're going to expand our compound angles. Alright, so I've expanded them, but please don't forget there has to be a minus there because of the question. So put a bracket because you're going to distribute that negative in the next step. Alright, and now please don't forget your cos 45 is a special angle, and so is your sine 45. But because 45 and 45 make 90, they're going to end up being the same special angle. Alright, so your cos 45 and sine 45 are both equal to root 2 over 2. And so we're going to just distribute this negative into the bracket and then simplify. Alright, and you can see that you have a root 2 over 2 cos x, and then you minus it. And then you've got a positive root 2 over 2 sine x, and then you minus it. So you're working with 0, which is our right-hand side. Alright, the last question for this video is 2 sine 30 minus x is equal to cos x minus root 3 over sine x. So I'm going to still start with the left-hand side because I can see a compound angle that I can expand, and it's going to have some special angles which will hopefully get me my root 3 on the right-hand side. Alright, so once we expand, we have the sine 30 and cos 30, which will be special angles, which are as follows: half and root 3 over 2. Then we're going to distribute the 2 in, and you're going to see that you're going to be left with cos x minus root 3 sine x, because the 2's will cancel from the denominators with the multiplying the 2 in, and that is your right-hand side. Alright, the rest of this worksheet will be in the next video. You'll work on question 5 and 6, which is a little bit more reductions, simplifying, identities, and some tougher questions.